Let's talk about this idea of completing the square. This is going to take the idea of solving quadratics with radicals, which this is what we just got done doing. And we're going to use that idea for this thing called completing the square, which is going to lead us to another way of solving quadratics that you'll probably love and use all the time. But I want to make sure that you understand how this is derived. And it'll also get us back to why the vertex is at negative b over 2a. All right, let's work this. Here is your standard. You can read that. Okay. First, what I'd like you to do is I would like you to expand each of those binomials, multiply them out on your own. So pause the video and try multiplying them out first. Go. Okay, hopefully you had a chance to do that. Let's walk through real quick. The first one I'm going to actually do by binomial expansion here. I'll actually rewrite it. The second one I'm just going to use the pattern. Okay, so I've got x times x is x squared. I've got x times 7 is 7x. I've got 7 times x is 7x. And I've got 7 times 7 is 49. When I combine these, I got x squared plus 14x plus 49. Okay? This is the same as that. Okay? Remember this thing here is a perfect square because I can rewrite it as x plus 7 squared. Okay. Now, with that idea, let's leave this here. With this idea, okay, what I want you to remember is when you're squaring this, right, you square this term, you square the n term, and then you get a middle term of double this times this, right? So x times 7 times 2 is 14. So let's do this one. So we're going to get x, I got x squared, negative 3 is plus 9. What's my middle term? Well, my middle term is going to be negative 3 times x times 2, so negative 6x, okay? There you have it. So hopefully that's what you got. If you didn't, hopefully this is ringing some bells, reminding you on how to do this. This is going to be very important, okay? Especially recognizing that this is a perfect square and that from here I can get that, all right? And that's what we're going to use here. Okay, so here, this probably looks crazy to you, which is fine, but hopefully by the end of this slide you'll understand. What I'm looking for here is what completing square does is we're looking for the missing amount here. Okay, what we're going to do is I'm going to find a number that I can plug in for, c, right? This is ax squared plus bx plus c. Okay, something for c here that makes this equation a perfect square. Okay, so we know that the pattern is the middle term is this times 2, right? So what I'm looking for is once I get here, right, how do I get my other n term? So I'm going to take a look at here. Okay, in order to get a middle term of positive 6x, I'm going to need to have plus 3 here, right? Because if I do x times 3, I get 3x, and then 3 times x is 3x together makes 6x. So then what I'm going to do is I'm going to look, okay, well then here, if I square the 3 to here, that's going to put a 9 there. Okay, so the number that I need to put in for c, okay, in order to make this a perfect square is 9. Hopefully you're following that, okay? Let me walk you through it one more time. In order for me to have a perfect square, okay, I would need this n term to be a 9, okay? I look here first and I say, okay, how do I look here, right, and I take the square root of x squared, that goes here. I look here and I say, okay, how am I going to get a middle term of positive 6x, okay? How do I get a middle term of positive 6x? When I write my binomial, it's half of this middle, right? If we go back here, if you remember, so this 14x is my middle term here, right? Well, that means this half of that was 7, because I'm going to do 7 times x, right? And we did it here. 7 times x and x times 7, and those together make 14. Same idea here, right? We took negative 3 times x, and then we doubled it to get negative 6x. So once we're here, what we're looking at is I want to go backwards. I want to say, okay, well, what is half of this? what will give me a middle term of 6? Well, that's 3. And then what does that give me if what is my end term here? If this is a 3, well, I'm going to take 3 and square it to give me 9. Okay, so 9 is what makes this a perfect square. And let's go ahead and check it. We'll plug in 3 on both sides, okay, and then I'm going to do x times x is x squared, and I'll do x times 3 is 3x, and so let's do this here, and then 3x, and 3 times 3 is 9, so that gives me x squared plus 6x plus 9, so it works. Okay? All right. Let's move on. Let's try using this idea, okay? So what we're going to do is, actually no, first let's practice. So what I want you first to do is I want you to come up with the end term. Actually, I'm going to change that first one. That first one is, I didn't want it to be that. Let's change this to, let's say, how about 12? 12 sounds good. Okay, change it to 12. All right, so what I want you to do is I want you to try to tell me what number would go on the end here, right? I think in the book they say, like, they'll put a plus C, and they'll say, you determine what is the middle term, like what value, right? What value of C makes this a perfect square? So that's what you'll end up doing, okay? So why don't you go ahead, try to figure out what is the end term there. Okay, so I'm going to take this, I'm going to look at them and say, okay, I'm going to square this. Okay, I took the square root of x squared, put x. I'm going to say, okay, in order for this thing to be a perfect square, right, I'm trying to figure out what does C need to be. Well, in order to get a middle term of negative 12x, I'm going to have a, well, this is not going to be plus. This is going to be a minus. So I'm going to get x minus what's half of 12x, or half of 12 is going to be 6, right? So if I did negative 6 times x times 2, that gives me negative 12x. Good. Okay. Well, then that means that C, right, is going to be 6 squared. Right? C is 6 squared. So what is, and that's actually, it's negative 6 squared, but what's negative 6 squared? That's going to be 36. So in order to make that a perfect square, right, I'm going to do x squared minus 12x plus 36, and then that's going to equal x minus 6 squared. Okay, now if you didn't have a chance to try the second one, go ahead and try to figure it out. What do you think C is going to be over there? All right, what did you get for the value of C? Hopefully you got, let's see, it should be 100. Okay, so how did I get that? All right, I look at this, I say the square root of x, okay, x squared, and then I'm going to look to see how do I make this a perfect square. Well, what's half of positive 20? That's positive 10. Then I'm going to look at 10, and I'm going to say what's 10 squared? That's 100. So C must be equal to 100. So I want to make it x squared plus 20x plus 100 makes this thing a perfect square. Good? Hopefully. Hopefully you're nodding your head or saying, yes, I totally get this, Mr. Clark, wherever you're watching this. Maybe you're in the car, on the bus, in your room, at the library. Okay, so now how does this help us? Well, we're going to use this as an alternate method of solving these equations. Okay, maybe you don't want to, maybe it doesn't factor, and maybe you don't want to graph it. Okay, maybe graphing it is going to be a big pain. Like sometimes, you know, you end up with those fractions in there, or you might actually end up with some irrational numbers, and it's just not going to be fun. So we're going to use this idea of completing the square to solve it, okay? And this is taking that idea of using radicals to solve the equations. All right, so I've got this thing set up for us, and what I'm going to do here is I'm looking for, okay, x squared plus 10x is equal to negative 8. What I'm going to do is I'm going to try to make the left side here, I'm going to try to make this a perfect square. Okay, I want this thing here to eventually look like this squared. And what's the point of that? The reason why I want to do that is so that I can take the square root of this and end up with just x by itself. Okay, that's the goal here, is that I want to figure out what x is. And so in order to do that, I'm going to manipulate both sides so that the left side here is a perfect square. And the right side I'm not going to care about until I actually take the square root, okay? If it's not a perfect square, fine, I get an irrational number. But the idea here is first is we're going to take this and we're going to make it a perfect square. Okay, so how do I do that? I'm going to take x squared plus 10x, okay? And I need to put some number in here to make it a perfect square. Well, what's that number? So I'm going to look at positive 10x. What's half of positive 10? That's going to be 5, okay? So I've got x plus 5. This is now my perfect square. So x plus 5 squared, 25. So what I'm going to do is I'm going to artificially add 25 to this left side. Now, as equations go, if I'm going to increase the left side or add 25 to the left side, then I must do the same to the right side. Otherwise, it's not equal anymore. Okay? So what happens is that left side becomes x plus 5 squared, and the right side becomes 17, because 25 and negative 8 makes 17. And now I have x plus 5 squared is equal to 17. And from here, I can go ahead and I can take x plus 5 squared is equal to 17. I can take the square root of both sides, take the square root of this side, and I'm going to get x plus 5 is equal to plus or minus 17, square root of 17. So x is equal to negative 5 plus or minus the square root of 17. Now I just solved it. Okay, and if you want to use a calculator, or you can estimate the square root of 17 should be about 4.1 probably. And then you could try graphing it. We could plot our x, we could plot the x-intercepts. So that's the idea of completing the square. Okay, you figure out what the end term would be, add it to both sides, and then use your square roots to solve. So you try. Go. All right. I'm going to start. If you get stuck here, if you didn't even know where to start, that's fine. So I'm going to do the first step, and then I'd like you to try pausing the video and going from there. In fact, it's just a good idea in general as we watch the videos. If you got stuck and I give you a step and you're like, oh, I see what to do, pause the video and then continue from there until you get stuck again, right? Or hopefully you get to an answer, and then we get to the end and maybe we have the same answer, maybe not. All right. So what I'm looking to do here is, if I were to look at this, it doesn't look like I can factor it. I could try graphing it. I don't really want to graph it. I'm going to use completing the square here. Okay. So what is this going to look like? I'm looking to try to find x minus something. Let's do this. I'm going to skip. So my recommendation was, if you're going to do this, you're going to want to skip a line. Okay. So I want this thing to look like x squared, x, and then this is minus 8x. So I'm going to minus something squared, okay? So what does that have to be? Well, right now I've got this negative 30 over here. So what I'm going to do is I'm going to say x squared minus 8x, and then I'm going to move that 30 to the other side so that it's out of my way. Then I'm going to say, okay, whatever value I get here and square it, I'm just going to put on both sides then. Okay, I'm going to put it here and here. So I'm going to add something and add something, right? So there's going to be a number, whatever this number is, squared here and here. Hopefully that makes sense. All right, so what is half of negative 8? Well, that's negative 4. Then what's negative 4 squared? Well, that's going to be 16. So then I'm going to do 30 plus 16. Okay, and now I've got x minus 4 squared is equal to 46. And I'm going to go ahead and I'm going to do x minus 4 squared is equal to 46 and take the square root of both sides. And I get x minus 4 is equal to plus or minus the square root of 46. So x is equal to 4 plus or minus the square root of 46. There we go. Okay. Go ahead and try that one. Now, this one, hopefully looked at some, wait a second, Mr. Clark, there's a 9x squared there. Okay, you have multiple options of what you could do. First thing you could do is, if you wanted, you could actually just divide by 9. You could divide everything by 9. Now, the issue you're going to run into there is you're going to end up with some fractions, which hopefully isn't a big deal, but I know a lot of you, it is a big deal. So, if you think about it, 3x or 9x squared is actually a perfect square. I can actually make this into 3x. Okay. Now, this just adds another layer of complexity to completing the square, but not one that is unreasonable. So let's do this. We'll do 9x squared plus 36x plus something is going to be equal to negative 11 plus something. Okay. So again, what I'm looking for is I'm looking for a number, right? Some combination to get me to 36. Okay. Well, I know that half of this is 18. Okay, well, I can't just put 18 in here because 18 times 3 times 2 is not going to give me 36. But if I take 18 and divide it by 2, I'm sorry, if I take 36 and divide it by 2, that gives me 18. But I'm also going to need to divide that by 3. Okay, and here's why. I'm going to get 3x and 6. Okay, so then let's try it. So it's a plus. So if I do 6 times 3x, I get 18x. Times 2 is 36. There we go. And I've got it. Okay. So then what am I adding to both sides? Well, then I'm going to add a 36 here, and I'm going to add a 36 here, and I'm going to end up with 3x plus 6 squared is equal to 25. Well, this one looks pretty nice because 3x plus 6, right? I'm going to take, well, we'll take the square root of both sides now. So 3x plus 6 is going to be equal to 5. So that means 3x is equal to, oops, this is plus or minus 5. 3x is going to be equal to 6 plus or minus, or negative 6 plus or minus 5. So 3x is going to be equal to either, let's see, negative 6 minus 5 is negative 11, or 3x is equal to negative 6 plus 5 is negative 1. So I'm going to get x is equal to negative 11 thirds, or x is equal to 1/3. Negative 1/3. All right. Hopefully that was mostly explanatory. I'm sure you'll have plenty of questions. Bring them to class. We'll do some practice. Don't worry. I'll get you. We'll get you through this. No problem. Okay. Thanks.